Hi, so far we have discussed about series and their convergence. We have basically focused on positive term series where your sigma UK, where your UKs were all non-negative, and we have discussed three tests with regard to that, that is the comparison test, the ratio test and a root test. Okay, so your series can in general need not be positive term series, it can have negative terms, it can have positive terms or anything, it can be in any pattern. Okay, so now we will be focusing on a special type of series called alternating series. Okay, the particularity or the feature of this alternating series is that the terms would be alternatively positive and negative in nature. Okay, suppose the first term is positive, then the second term would be negative, the third term would be positive, etc., etc. Or similarly, if the first term is negative, the second term would be positive, the third term would be negative, like this. So basically the terms would be alternating in their signs. Okay, so it will have a general form like this. Suppose it will be like this, u1 minus u2 plus u3 minus u4, okay, plus u5, etc. So where this ui's are basically greater than or equal to 0. So the first term here is actually positive, the second term is actually minus u2 which is negative, the third term is u3 which is positive, and the fourth term is minus u4 which is negative. So basically it is alternating between plus and minus, or it will be like minus u1 plus u2 minus u3 plus u4 minus u5, etc. So generally the alternating series will have the format like this, minus 1 raised to k uk, or it will be simply sigma minus 1 raised to k plus 1 uk, where k varies from 1 to infinity. Okay, so when it is minus 1 raised to k uk, it will be like this one, minus u1 plus u2 minus u3 plus u4, like that. When it is minus 1 raised to k plus 1, it will be simply be u1, okay, minus u2 plus u3 minus u4. So see, observe that we have taken here the ui's as non-negative, but ui's are not actually the terms of this series. The terms of this series are minus u1, u2, minus u3, u4. For simplicity, I am just taken that ui's as non-negative. The terms of these series are actually u1 minus u2, u3 minus u4, etc. So you may have understood the pattern. Here the terms are alternating in signs between positive and negative. One example is 1 minus 2 plus 3 minus 4 plus 5, etc. But 1 minus 2 minus 3 plus 4, this is not an alternating series because you can see that both the consecutively two terms have negative sign. So this is not an alternating series, this is an alternating series. Here 1 minus 2 plus, so basically it is alternating in sign. Okay, similarly one familiar series is 1 minus 1 by 2 plus 1 by 3 minus 1 by 4 plus, etc. So this is similar to your harmonic series, 1 plus 1 by 2 plus 1 by 3 plus 1 by 4. So here you can see that the terms are alternating in their signs. So this is an alternating series. Okay, suppose if my series is minus 1 minus 2 plus 3 minus 4, this is not an alternating series because here two terms, consecutive terms, are having negative terms, negative sign itself. So basically the signs are not alternating successively. Okay, so this is not an alternating series. So I hope you understand now the pattern of alternating series. So in this session we will discuss when this alternating series will be convergent or not. Okay, when the alternating series can be convergent. So here are some examples of alternating series. So there is only one test regarding to this alternating series. It is actually devised by Leibniz. So basically it's very simple test. Okay, suppose we are so this is the general form of the alternating series. Okay, so this is the general form. So what's the test? The test is actually consists of two steps. Okay, in the first step, this series would converge if it satisfies two conditions. The first condition is your limit k tends to infinity, uk should be 0. That's the first condition. Okay, just this is a condition for convergence also. You should know that the kth terms effect should be nil or negligible. That's why they say that limit k tends to infinity, uk should be 0. Okay, and the second condition is that your uk's should be monotonically decreasing. It should be monotonically decreasing. What do you mean by that? That means your uk should be greater or equal to uk plus 1, or your uk should be greater than or equal to uk should be greater or equal to uk plus 1. Okay, for example, so if you look at this series, this series is not monotonically the terms. So here the UKs are 1, 2, 3. Here the UK is actually K. This series is not monotonically decreasing because the kth term is actually K. The K plus 1 term is K plus 1. So basically it is not monotonically decreasing, but it is monotonically increasing. Okay. Now if you look at this series, you can see that the kth term is actually 1 by K. The K plus 1 term is actually 1 by K plus 1. So if you look at these two terms, which is bigger, obviously 1 by K would be bigger because K is less than K plus 1. So if you take the reciprocal, the signs would change. 1 by K would be greater than 1 by K plus 1. For example, if 2 is less than 3, your 1 by 2 half is always greater than 1 by 3. So when you take the reciprocal, the sign will reverse actually. So the terms of this series is actually monotonically decreasing. So if you look at this series also, you can see that the terms are actually monotonically decreasing. If you look at this term, if you just ignore this term, the terms are actually monotonically decreasing. Even if you don't ignore also, it's true. You don't look at the signs here. So here UK, you are taking UK without the sign. So you basically, these terms are actually monotonically decreasing. Okay. So if these two conditions are met, we will say that the series sigma minus 1 raised to k UK or sigma minus 1 raised to k plus 1 UK, it is convergent. So this is the test for alternating series. So this is a test. Okay, so let us now look at one simple example. So can you check whether this alternating harmonic series, so already in the harmonic series 1 plus 1 by 2 plus 1 by 3 plus 1 by 4, basically this is actually divergent because your P is actually equal to 1. Okay. Now if you look at the corresponding alternating series, which is 1 minus 1 by 2 plus 1 by 3, let us check whether this is convergent or not. Since this is an alternating series, we will be applying the alternating series test. So what is your UK here? Your UK is without the sign, just 1 by K. So what is limit UK? Limit UK is actually 0. So the first condition is met. Okay, and what is the second condition? Second condition is that your UK should be monotonically decreasing. So as we have discussed, your UK is already 1 by K, which is anyway greater than your UK plus 1, which is 1 by K plus 1. So the second condition is also met. So that means this series is actually convergent. So this alternating series is also convergent. Okay, so but you can see that this corresponding series of positive terms, okay, or we will say that the series of absolute terms is not convergent, it is divergent. Okay, so that is one simple observation we will make. Here you can see that this series is actually convergent, but the series corresponding to its positive terms or the absolute terms, that is 1 plus 1 by 2 plus 1 by 3 plus etc. Since it's a P series, P is equal to 1, this is actually divergent. Okay, so this was a simple observation which will help you in the next session. Okay, now let us try to do some simple problems related to this alternating series test. Okay, now let us look at some simple problems. Okay, so here basically to prove monotonicity, that is actually sometimes it may be difficult. So so basically you have to show that the UKs are monotonically decreasing. So that means your UK should be greater or equal to UK plus 1. So two ways are there. One is you can simply form the difference UK minus UK plus 1 and show that this is greater or equal to 0, or UK by UK plus 1, if you take it, you should get it actually should be greater or equal to 1, or your UK plus 1 by UK should be less than or equal to 1. So you can use any of these methods. There are other methods also which employs calculus, but it is not required for us now. So let us just look at these two type conditions, which is your UK plus 1 by UK should be either less than or equal to 1 because your UK is bigger, or your UK minus UK plus 1 should be greater or equal to 0. So this is how we will try to prove monotonicity. Okay, now let us look at some problems here. So let us look at this problem here. K into K plus 3 by K into K plus 1. Okay, so here your UK, don't look at the sign while doing alternating series. You can see that this is already an alternating series because it is minus 1 raised to K plus 1. So when it is K plus 1 is positive, when your K plus 1 is even, you will be getting it as positive, and your K plus 1 is odd, you will be getting it as negative. Okay, so if you look at this one, so what is your UK? Your UK is actually K plus 3 by K into K plus 1. So we have two conditions to be followed if it is convergent. One is you have to find your limit UK. So what is your limit K tends to infinity UK? So limit K tends to infinity UK is actually K plus 3 by K into K plus 1. Take the K maximum power outside. So it is K into 1 plus 3 by K square into 1 plus 1 by K. So when you apply the limits, there is 1 by k in denominator, this 1 by k will become 0, and here again you will be getting 1 by k, so your limit would be simply 0. That means limit of uk is actually 0, so that condition is satisfied. Now let us look at monotonicity. So how will you what is your uk plus 1? First of all, your uk plus 1 is actually, your k should be replaced by k plus 1, so it is k plus 1 plus 3 by k plus 1 into k plus 1 plus 1, which is nothing but k plus 4 by, right, k plus 1 into k plus 2, right. Okay, so what is your uk plus 1 by uk? It is nothing but k plus 4 by k plus 2 into k plus 2, right, k plus 2 into k plus 1, right. So okay, so k plus 1 by uk, when you take uk you will be using the reciprocal, so it will be k plus 3 into k into k plus 1. Okay, so please write it yourself, only then you will understand. So your k plus 1 will get cancelled out, so it will simply be k square plus 4k in the numerator divided by denominator will have k plus 2 into in denominator you will have actually so numerator you have k plus 4, so numerator it is k plus 4 into, so 1 second, k plus 4 into k plus 1 into k plus 2, and your uk plus 1 is actually, so it is so k plus 4 into k plus 1 into k plus 2, and otherwise it is k plus 3 into k plus 1. Okay, so your k plus 1 will get cancelled out, so your entire thing will be actually k square plus 4k. Okay, so please correct me if I am wrong, divided by k square plus 5k plus 6. Okay, so k square plus 4k by k square plus 5k plus 6, this is actually your uk plus 1 by uk. Okay, now what can you say about this? So basically your k is actually the integer, okay, the positive integer, because it is an index. Okay, so k is from 1 to infinity, so definitely your k square plus 4k should be less than or equal to this k square plus 5k plus 6, because your k is actually positive integer, so your k square plus 4k will be less than k square plus 5k plus 6. Why? Because this k square plus 5k plus 6 I can write it as k square plus 4k plus k plus 6. That means this one is a bigger quantity, so your denominator is a bigger quantity. That means this should be less than or equal to 1, or in other words your uk plus 1 uk is less than or equal to 1, that is your uk plus 1 is less than or equal to uk, therefore it is monotonically convergent. So it's basically monotonically decreasing. So then also we can say that since limit of uk is 0 and it is monotonically decreasing, we can say that this series is again convergent. Okay, so please try to do it yourself and try to convince yourself that uk plus 1 by uk is less than or equal to 1. Okay, so very simple problem, only if you write down you will understand, so please try to write it down by yourself. Okay, moving forward, let us look at this question. So here basically they have not given you the value of uk, so can you just guess the value of uk by looking at the terms? So the first term it is 2. Okay, so the second term it is 3 by 2. So for 2 I have, so second term I have 3 in the numerator, so it can be k plus 1 by, and for second term I have 2 in the denominator, k by k. Okay, so let us verify. For the third term I have 4 in the numerator, so it is k plus 1, and for third term I have 3 in the denominator, so k plus 1 by k. So your uk is actually k plus 1 by k. Don't write the sign here, we have just taken uk only. Okay, so this is your ukth term. Now what is your limit k tends to infinity uk? Your limit k tends to infinity uk is actually limit k tends to infinity k plus 1 by k. What's the value of that? It is 1. If you take k outside, you will be getting k into 1 plus 1 by k, so it is simply 1. So that means your limit uk is not equal to 0, therefore this series is divergent. Okay, very simple. Okay, one more question I have. So this is the question. So first of all, here uk is not given, so please try to write down uk. Can you just guess uk? For first term you have 1 by 2 cube. Okay, so for first term 2 is coming, so k plus 1 cube. So second term you have 1 by 3 cube, so it is actually 1 by k cube into 1 plus 2. Okay, for the third term you have 1 by 4 cube. Okay, so 1 by, sorry, it is 1 by k plus 1 cube. Okay, so 1 by k plus 1 cube into 1 plus 2 plus 3. So can you guess? It is 1 plus 2 plus etc plus k, or it is simply b. So this is your ukth term, because it is, if you just compare it, it acts like this, because For the second term I have 3, so it is k plus 1 cube. So and again 1 plus 2. And for third term I have 1 plus 4, 1 by 4 cube, 1 plus 2 plus 3 etc. So it is actually 1 by k plus 1 cube into 1 plus 2 plus etc. k. So if I simplify, this is actually k into k plus 1 by 2 into k plus 1 cube, or simply k by 2 into k plus 1 square. So please correct me if I am wrong. So k by k plus 2 into k plus 1 square, right? Okay. Now what's the limit of uk? So limit uk will actually be limit of uk will be limit of k by k plus 1 square. You can take k square outside, k will be their numerator, 1 k will get cancelled out, but still there will be k in the denominator, so we will be getting the entire quantity as 0. So limit uk is actually 0, so the first condition is satisfied. Okay, so either you can take uk, now for second condition you can either find uk plus 1 by uk or uk minus uk plus 1, that's your choice. So you can use any method. Suppose it is uk plus 1 by uk, what will I get? Your uk plus 1 will be simply be k plus 1 by 2 into k plus 2 the whole square, and your uk is actually k into 2 into k plus 1 square, so it is actually k plus 1 the whole cube by k into k plus 2 the whole square. So from here it is not obvious whether numerator is bigger or denominator is bigger. So let us look at the second method, which is uk minus uk plus 1. So what is uk minus uk plus 1? If you look at that, if you approach using that method, your uk is actually k by 2 into k plus 1 square minus k plus 1 by 2 into k plus 1 by 2 into k plus 2 square. So you can take 2 outside, and if you look at the LCM, it is k into k plus 2 the whole square minus k plus 1 the whole cube. So what will you get? Divided by your k plus 1 square into k plus 2 square. Okay, so if you just expand and simplify the numerator, it will be simply be 1 by 2 into, it is k square, so k cube plus 4k square, okay, plus 4k. So basically k plus 2 the whole square is k square plus 4k plus 4. If you multiply with k, you will be getting k cube plus 4k square plus 4k minus k plus 1 the whole cube is again k cube, okay, minus plus 3k square plus 3k, okay, plus 1 divided by the denominator property. So here your k cube, so please write to yourself, only then you will understand. Your k cube and k cube will get cancelled out. 4k square minus 3k square will be getting it as 1 by 2. So please write it to yourself, 1 by 2 into, so 4k square minus 3k square, just k square, 4k minus 3k, just k square plus k plus okay, minus 1. Okay, so k square plus k minus 1. Okay, divided by denominator you have k plus 1 the whole k plus 1 the whole square into k plus 2 the whole square. Okay, so this is your denominator. Now if you look at this quantity, whether is it positive or negative, your denominator is positive and your numerator is actually k square plus k minus 1. What can you say about that? K square plus k minus 1. So your k is actually from 1 to infinity. So in every case, your k square plus k minus 1 will always be greater than 0. Okay, why? So if it is 1, you will be getting 1 plus 1, 2 minus 1, again 1. If it is 2, you will be getting 4 plus 2, 6 minus 1, 5. So it is going on increasing. So basically, your k square plus k minus 1 is greater than 0. That means your uk is actually greater than uk plus 1. So these UKs are monotonically decreasing. So it is reducing in size as we go forward. Okay, so that is why. So these are monotonically decreasing. So this series is also convergent. Okay, so I hope that is also clear. Okay, so this is alternating series test. Now let us conclude this session by a small discussion on absolute convergence. So in general, your series may not be a positive term series or it not be an alternating series also. So it can be, so basically your series need not be a positive term series, or it need not be minus 1 raised to k uk also, an alternating series also. It will be like minus 2, minus 1, minus 1 by 2, plus 1 by 3, minus 1 by 4. So you can see that the negative signs are actually random here. So basically it need not be a positive term series, it need not be alternating series. Now how will you test for its convergence? Okay, it's very simple. One way is you look at the absolute term series, corresponding absolute term series, that is your 2, plus 1 plus 1 by 2 plus 1 by 3 plus 1 by 4. So you are just taking the absolute terms of the series. Okay, that's why it's called absolute term series. Now if this series is convergent, we will say that the given series is absolutely convergent. Okay, why? The absolute term series, if the absolute term series is convergent, we will say that the given series is absolutely convergent. Okay, and we have a result which there's no need to study the proof. The result states that every absolutely convergent series is convergent. So if you can show that this series is absolutely convergent, you can usually show that using many of the comparison tests, ratio tests, root tests, because it is actually a positive term series. So you can use you can employ those tests. Okay, so if this series is convergent, we will say that the given series is absolutely convergent, and hence it is convergent because every absolutely convergent series is convergent. Okay, so this is the definitions. A general series sigma uk is said to be absolutely convergent if the series of absolute values is convergent. Okay, for example, if you look at this series 1 minus 1 by 2 plus 1 by 3 minus 1 by 4 plus etc. If you take the absolute terms, it will be 1 plus 1 by 2 plus 1 by 3 plus 1 by 4. Now this series we know it is divergent. Okay, so we will say that this given series is not absolutely convergent. Okay, not absolutely convergent. On the other hand, if I am taking the series 1 minus 1 by 2 square plus 1 by 3 square minus 1 by 4 square plus etc., the corresponding positive term series is 1 plus 1 by 2 square plus 1 by 3 square plus 1 by 4 square plus etc. This is your P series with P is equal to 2. Therefore, this series is convergent. So, we will say that the given series is absolutely convergent because the absolute terms are actually convergent. So, we will say that the given series is absolutely convergent, and hence since it is absolutely convergent, the given series is convergent. Okay, so it is convergent. So this is how you will apply for any given series. Okay, so we will say that this series is absolutely convergent and this series is not absolutely convergent. Okay, so these are just some notations and definitions only, nothing much is there. It's very simple ideas. Okay, now if I look closely at this series, already we know that this is an alternating series. Now if you apply the Leibniz test, it is actually convergent. Okay, so it is actually convergent. Okay, why? Because your uk is 1 by k, already we shown that, so it is less, limit of uk will be 0, and already 1 by k is always greater than or equal to 1 by k plus 1, so the second condition is also satisfied. So this is actually convergent series only, but it is not absolutely convergent. So such series we call those series as conditionally convergent. Okay, we will call those series as conditionally convergent. Okay, what's conditionally convergent series? A series which is convergent but is not absolutely convergent is called a conditionally convergent series, because it should have those negative conditions, only then it will be convergent. For example, this series, okay, is actually convergent, but its absolute term series is not convergent, so we will say that this series is conditionally convergent. Okay, so this series is so, but for the example of this case, you know that this series is convergent and also the absolute terms are also convergent. For them we will call them as absolutely convergent series. Okay, so these are some simple notations regarding to this convergence. Okay, so this is called absolutely convergent series. Okay, so sigma uk is absolute, so I hope it is clear. And what's the benefit of absolutely convergent series? Okay, the benefit of absolutely convergent series is that if a series is absolutely convergent, we can definitely conclude that the given series is convergent. This is usually useful in cases when your series does not have a set pattern, like it may not be a positive term series, or it may not be an alternating series, it may be just a general series like this, -1, -2, +3, -4. So it can be a general series without any pattern. Now if you can show that it is absolutely convergent, we can conclude that the given series is convergent. Okay, so I hope it is clear. And one more concept we have introduced, which is called conditional convergence. What is that? So it is very simple thing. So if the given series is convergent but its absolute terms are not convergent, we will say that the given series is conditionally convergent. For example, our series 1 minus 1 by 2 plus 1 by 3 minus 1 by 4, you can see that this series is convergent by alternating series test, but its absolute terms 1 plus 1 by 2 plus 1 by 3 are not convergent because the P series of P is equal to 1. So we'll say that this series is conditionally convergent. Okay, so here are some examples. This series is actually conditionally convergent, already we have discussed that. And again, this series is absolutely convergent because it is, if you take the absolute terms, it is 1 plus 1 by 2 square plus 1 by 3 square plus etc. So it is absolutely convergent. And one more, let me make a small remark here. So for comparison test, I have already discussed one type of, there are many versions of comparison test. Okay, one version which we have discussed is if there is a series is UK and if you can find a VK such that limit UK by VK is finite, we will say that UK and VK are convergent together. So this was the comparison test we studied. Now there is a similar another comparison test also. Basically comparison test is for positive term series, so beware of that. So we are already discussing positive terms of series here. Okay, suppose your UK is less than or equal to VK. Suppose your UK is less than or equal to VK and suppose both of them are positive term series. Okay, now just think of it as logical. Think of it as logically. Suppose your sigma VK is convergent. Suppose your sigma VK is convergent. That is, suppose the bigger series is convergent. We can say that sigma UK also will be convergent. Why? Because VK having bigger terms, still sigma VK is convergent. Therefore, it means sigma UK will also be convergent. So this is another form of comparison test. Okay. So similarly, there is another form also. Suppose your UK is divergent. Sigma UK is divergent. Suppose the smaller series itself is divergent, then sigma VK will also be divergent. So if the smaller series in itself is actually going to infinity, your bigger series also we should go to infinity. So that is another version of comparison test. It was not required for you, so but I'm just telling you so that I can illustrate a small example here for you. Okay, so if you look at this series sigma cos k by k square. Okay, if you look at this series cos k by k square, if you look at the positive terms here, so if I take modulus of cos k by k square, your k square is always positive, so it will simply be, if I consider this series mod cos k by k square, you always know that mod of cos is always less than or equal to 1. Okay, so modulus of cos k by k square is always less than or equal to 1 by k square because the maximum value of cos k is actually 1. Okay, now you know that the series sigma 1 by k square converges. Why? It is the P series P is equal to 2. Therefore, by comparison test, this series also will converge. That is, that series of absolute terms is converging. So this is absolutely convergent series, and since it is absolutely convergent, we will say that cos k by k square, the original series also will be convergent. That is, so cos k by k square also will be convergent. Okay, I hope that is also clear. Okay, so this is the some simple illustrations. Now we will discuss a test. There is no test actually, but actually it is your ratio test only. You are just taking the positive terms only. So for simplicity I am telling you, there is no need to study any particular test for absolute convergence. For absolute convergence, what you do is that you just take the absolute terms. Okay, and once you take the absolute terms, it is your positive term series. So you can apply the ratio test, comparison test, and also root test for testing whether the series is convergent. So there is no particular test, but if you want, I can just state a ratio test for absolute convergence here also. Okay, so there is no particular test needed. So if you are given a series and if you are being asked to find the test for absolute convergence, what you do is that you just take the positive term series. Now if it is a positive term series, you can apply either ratio test, root test, or comparison test. So applying those, with those results, you can test whether it is absolutely, whether it is convergent. If it is convergent, we will say that it is absolutely convergent, and hence it is, the given series is also convergent. So there is no new test as such for absolute convergence. It is the same old test only. Okay, so this is simply a condition which is mentioned in the textbook, the same test which you have studied in the positive term series. Now let's do one problem here. Okay, let us try to do some problems here. So look at this series. So I need to test whether this series is absolutely convergent. So what I will do, I'll just take the positive term series, which is nothing but 2 raised to k by k factor. So this is a positive term series. So I can apply a ratio test, root test, or comparison test. So which will be easier? Comparison test is obviously difficult, not possible, and root test is not needed because your raised to k is only for 2. So obviously I'll take the ratio test. So ratio test, I'll look at uk plus 1, which is nothing but 2 raised to k plus 1 by k plus 1 factorial, and your uk is 2 raised to k by k factorial. So what is your uk plus 1 by uk? Your uk plus 1 by uk is nothing but 2 raised to k plus 1 by k plus 1 factorial into 2 raised to k by k factorial. Okay, so we have done many problems like this. So it is your k factorial and k plus 1 will factorial will get cancelled out. It will simply be k plus 1. So it is 2 by k plus 1. Why? Because k plus 1 factorial is 1 into 2 into etc. k plus 1. K factorial is 1 into 2 into etc. k. So it is 2 by k plus 1. So limit k tends to infinity, 2 by k plus 1 is actually 0, which is less than 1. Therefore this series is convergent. Okay, so the series of absolute terms itself is convergent, so therefore this is absolutely convergent, and since it is absolutely convergent, obviously this series is convergent. Okay, so this is how we will approach these problems. So this is called absolutely convergent. Okay, very simple. Okay, in some problems they can give you an alternating series and they ask you to find whether the series is absolutely convergent or conditionally convergent or divergent. So in such problems it will be 3-step process. First you will take the positive terms, you will apply any of the 3 tests, ratio, root or comparison test. Now if it is convergent, we will say that the given series is absolutely convergent. Suppose it is not absolutely convergent, now if you look at the given series, if it is an alternating series, apply the alternating series test. Now if it is convergent, we will say that it is conditionally convergent, else it is divergent. So such problems can also be asked, but there is nothing new, just the same old concepts which you have been using. Okay, we will do one more problem here. So look at this problem here. So this series also, just check it out. So which the series is 2k minus 1 factorial by 3 raised to k. So for testing absolutely convergence, I look at the positive terms, which is nothing but sigma k is equal to 1 to infinity 2k minus 1 factorial by 3 raised to k. So what is your uk plus 1? Your uk plus 1 is nothing but 2k minus 1 so it is 2, so it is basically 2 into k plus 1, replace k by k plus 1 minus 1 by 3 raised to k plus 1. So 2 into k plus 1 minus 1 factorial by 3 raised to k plus 1. So it is 2k plus 2 minus 1. So it is 2k plus 1 factorial by 3 raised to k plus 1. So what is your uk? Your uk is simply 2k minus 1 factorial by 3 raised to k. So what is your uk plus 1 by uk? So please write it by yourself. It is actually 2k minus 1 factorial into 3 raised to k. So this is the ratio we will be getting. You can simplify it. So 3 raised to k will cancel, 3 raised to k plus 1 will cancel, we will be getting 1. And what is 2k plus 1 factorial? It is 1 into 2 into etc. 2k minus 1 factorial, 2k minus 1 into 2k into 2k plus 1. So when you cancel these two, we will be getting 2k into 2k plus 1 divided by 3. So when you take the limit, what will you get? Limit k tends to infinity, you will be getting it as infinity, which is greater than 1. Therefore this series is not absolutely convergent. This series is not absolutely convergent. So this is how you will check absolute. So there is nothing new in testing absolute convergence. Okay, there is nothing new, just the same old concepts only. You are just taking the positive terms and then discussing whether it is absolutely convergent or not. Okay, so that's it. So that's the end of this module. Okay, so in the next session onwards, we will start with the final module, which is Taylor series and Fourier series. Okay, thank you.